Morning to everyone who's joined us. Well, from the UK, good morning. And thank you for taking this time to join us to the second module of the International A-Level Mathematics. Um, my name, if you haven't joined us before in any of the previous sessions, I'm a credible specialist for Pearson at Edexcel. I work alongside my everyday job, day-to-day job, which is a deputy head teacher at a grammar school in the UK, King Edward School. And that's one of the reasons why this is a half term, which I am able to then support teachers across with the maths qualifications. In terms of your expectations for this session, I'd just like to remind you that if you are expecting any insights regarding the latest assessments or exams, that's a different session, which is also recorded and you'll be able to find online on our qualification site. If you have any problems with finding that, please ask me at the end and I can show you where you can find that as well. If you were with us in the previous session on the previous module on Monday, that was a bit more informative. We will be doing about 4 activities today together. I will also be entering you into a breakout room in a few minutes after I introduce a few facts regarding the way the assessment objectives are put together, so that you have an opportunity to discuss between you and then come back together. So there will be that opportunity as well. Throughout the session, if you have any questions, please use the chat. So I'll be looking at the chat on my side, which is why I'm looking towards the side and not always straight here. I've got another monitor there. So I can answer at any point that I can. If there are generic questions or questions regarding your own school, please leave those questions towards the end. I'll make sure we have time at the end to answer any of those questions. Claire's already mentioned about the delegates booklet. We will need the delegates booklets because I won't be able to share all the questions, mark schemes for some of the activities. So if you haven't downloaded that yet, Claire had the WeTransfer link earlier on. Claire, if you can hear me, if you can maybe repost that on the chat. So anyone who's joined us a few minutes ago, please then click on that link and download that if you haven't received it yet. With regards to the slides that I'm using today, Claire will also send you another link later on at the end when we finish towards the Q&A, so you can download the slides before you go, and then you can then have them again together with the delegates booklet. So if you want to refer back or share any of this information with any other colleagues in your school, you may do so. The recording for this session and the previous sessions will also be available on the qualifications website, but later on it won't be immediately. With regards to certificates, because those were questions I've been asked over the last few days while I was doing the international GCSE and A-level modules, that should be sent later on today. So they will use your email, so as the email that you received when the link to this session here, you will receive also your certificates. You'll also have a feedback form, which you might have to complete first before receiving that. So please look for that later on today. If you have joined me in the previous days or the previous module, I will have to go through a few key points for anyone who's new. It won't be as much detail as module 1, so please bear with me with that. So while I share a few information regarding the qualification and Pearson, and then we'll start with the assessment objectives. So the agenda for today, just so that you can see the difference between module 1 and module 2. Once I have the welcome and introduction with regards to Pearson as well, I will give some information regarding the assessment objectives of the International A-Level, explaining the rationale and how that guides the examiners of how to put the assessments together. It's worth noticing and knowing how they work, so that as you choose exam questions or create mocks or other homework pieces, or while we teach our students as well, we are aware of those assessment objectives and train the students as well of how to approach different problems, but also the way to think mathematically as well. So we'll go into more details with that one, and then look how the assessment objectives guide the marks as well within the mark schemes. doing those tasks myself and working with other colleagues as well, it does take some time sometimes to actually having a look and trying it ourselves so that we can better understand them, because there's a crossover between them like anything else in maths. And therefore, doing tasks like the ones we're going to do today then help us better understand the creation of the papers, and therefore the teaching and preparation of our students towards them. And then linking marks with progress through a question, we'll have a look at that. And then finally, any support, and then giving you the opportunity to ask me any other questions before we conclude. The actual objectives for today's session, I'll read those out. They're on the screen right now. Understand the assessment objectives for the qualification, understand the question types of the qualification, understand the mark schemes, practice using the mark schemes on exemplar student work. And that's something that I've been highlighting the whole week with regards to how useful it is to then take a piece of work that's already marked by an examiner and then seeing if we can give those marks in the same way as them. It's a way of standardization as well, I guess. And then learning about the support provided by Pearson around the assessments and exams. So again, I'd just like to welcome you on behalf of Pearson on joining us on this introductory session on International A-Level. For anyone new, I'll just reiterate here that we are the UK's largest awarding organisation with a heritage that stretches back over 150 years. We award qualifications to over 3.5 million students a year, and we work alongside 6,500 schools, colleges, and employers globally. We mark over 10 million exam scripts every year, and then we operate in about 70 countries worldwide, which is also nice to see. And if while we talk, when you have the opportunity to talk with between you, it's nice to see that we have colleagues around the world who are facing different challenges, but there's a common trend when it comes to the mathematics as well. And that would be nice to hear as well when there's an opportunity later on to unmute yourselves. So if I now go into the assessment objectives, just to explain a few things here. So just to understand, I've mentioned last time that this specification, we need to be following the specification and not certain textbooks. Textbooks are there to support us with the teaching, but it's the specification. We need to ensure that whenever we buy new textbooks, we ensure that it covers the specification thoroughly. And if it does emphasize on one or the other, make sure the specification does the same. So that specification describes the content of what is to be learned, and the assessment objectives is what the student has to do to demonstrate the learning. And those are important. So putting those two things together, the examiners have to then create those exam papers. And I'll show you how the weighting goes as well in the next few slides. The content differs for each module on the International A-Level Maths. The assessment objectives span each module, although the number of marks allocated to each assessment objective differs from module to module. And again, once I put you a table to actually see the framework behind it, you should be able to understand as well what I mean by that as well. So when we talk about content, we're talking about the facts, the techniques, the relationships, and the models that students need to learn. Whereas the assessment objectives, it's about how they have to, what they need to do to demonstrate the knowledge, the facts, the techniques, and the relationships, to demonstrate the applications of fact, techniques, and relationships to solve problems, and to demonstrate processes to model real situations, and to interpret results of the calculations involving models. So they go hand in hand, but the assessment objectives are there to allow the student to demonstrate, and as they put the questions together, that's the focus of the examiners. Now, the actual detailed assessment objectives are in your delegates booklet as well, and we'll refer to them later on. There are 5 for the International A-Level Mathematics. They're on the screen right now. That's the first one: recall, select, and use knowledge of mathematics, facts, concepts, and techniques. Second one is construct rigorous mathematics arguments and proofs, and the construction of extended arguments for handling substantial problems in unstructured form. The third one is recall, select, and the use of knowledge of standard mathematical models to present situations in real world. And the fourth one is comprehend translations of common realistic context into mathematics, interpret results. And the fifth one is use contemporary calculator technology and other permitted resources. So those are the 5 assessment objectives. They're in the delegates booklet. They're under activity 2. So if you have your delegates booklet, which I'll put on the screen right now. So it's this one here. So you should have downloaded this one. If we scroll down to the second activity, there they are there. So you can refer back to them at any point. A quick way of remembering them, but it's quite broad this way, but it's worth noting down. Think of it as the assessment objective 1, the do it. Assessment objective 2 is about show it. Assessment objective 3 is model it. The fourth one is interpret it. And then the fifth one is about calculate it. So that might be worth actually noting down. I'll give you a minute to do that. So that as we discuss or as we look at problems, we're thinking of this. Now, again, you might when you're looking at problems, you might want to understand a bit more whether that fits in with assessment objective 2 or 3. I would therefore go to the delegates booklet and look at the actual definitions of those. So what do I mean by that? Let's have a look at an example here. So an example of an assessment objective 1 question. So this one here, given that y equals 4x squared minus 3 over root x, find dy dx. This one here is an assessment objective 1. And then an assessment objective 2 question is a more of a show and prove, the kind of linked with that. So you can see the second question there, the length in centimeters of the 2 shorter sides of the right angle triangle are the following. Show that the length in centimeters of the longer side is 2√3. So that's the show and prove, and they're generally linked with that. So you can see there the difference between the two. So if I go back to what I said, assessment objective 1 is a do it. So find, there's a command word there, find, whereas the second one is show the length, and therefore you have that, you have those two. So that's a quite straightforward one. We'll see more complicated problems, and in other bigger problems, you'll see that you will have more than one assessment objective in those questions. If I give you another example there, so and on this slide here, so assessment objective 2 also refers the construction of extended arguments for handling substantial problems in a structured form. So if a student has to think about different facts and show an argument, not necessarily a written one in words, but actually shows the arguments they have to put together, that's also an assessment objective 2. Now, there are different ways of approaching a problem here. When you have to show that it's almost like proving an identity here. And there's different approaches to that. You could simplify the left-hand side, you could simplify the right-hand side, and then if you do on either side, you need to make sure you have a conclusion there to state and show that both sides therefore are simplified to the same things. Or that you could do the typical of taking the left-hand side and do following different arguments, then different steps. You can then show that it then turns into the right-hand side. So the important one, though, is to finish with, especially with the show and the prove, to finish with a conclusion there that brings the whole problem together. And a lot of students then miss that bit and end up losing a mark for that one. At any point, if you'd like to ask or question anything on what I'm saying, please use the chat. If I look at an objective 3 problem here, so the population in millions of a country is given by this, where t is the time in years, write down the initial population. Now, I need to emphasize that the assessment objective 3s are not just for population change. This is just an example. Other examples is like modeling investments from Pure 2. And we will look at other problems as we go along. I just wanted to give you an example of each an example of a question with each assessment objective, so that just to clear the distinction between them. if we look at this problem here, so in this one here, we have, if we think about the 5 assessment objectives, you have f of x equals to 8x minus 5 over 2x minus 1 times 4x minus 3. And the first one is express f of x in partial fractions. And that's a do it kind of assessment objective there, because it's telling you the instruction is just express it. So we can see from there that that's the part A is just an assessment objective 1. But I said the second one is an assessment objective 4. Now, if we go about, if I go back to the 4 criteria, the 4 is interpreting it. Now, in this case here, it's about interpreting the extended arguments. Here in part B, the hence implies interpret. So sometimes when you see the hence, it's about interpreting what you've done in the previous one. How does that follow into to help you solve this one here? And therefore, there's an assessment objective 4 behind that. Now, if errors are made in part A, it's still possible to get the marks in part B through follow-through kind of marks. This example comes from a recent paper 4, but it's that hence word there that you could look for to kind of see the interpreting as well. So it's not always like those other problems where you have to interpret the graph and write a sentence. There's also within the algebra here this type of examples. And then finally, if we look at an assessment objective 5 question, so you have this one here. You have to complete the column for x equals 0.75, giving the value of x correct to 3 decimal places. And you're meant to use the trapezium rule to calculate an estimate for the integral up there. Now, from here, you can see that it's the command, it's actually the command word is actually calculate. So in this case here, it's sensible to use a calculator or use the formula book. And that will be an assessment objective 5. We should note that only the value of f there is required to be calculated, that one value there. But again, it's the process that goes into students' minds as well and how they put that together, or the fact that they have to use the calculator that makes this into an assessment objective 5. If we then look at how like I mentioned, if we now look at overall how the assessment objectives are given within each pure paper to start with, you can see that the P1, P2, P3, P4 on different rows, and the different columns have your different assessment objectives. If we see that, we can see that from paper 1, the pure 1, there's more marks for assessment objective 1 compared to the other ones. Assessment objective 2 seems to be consistent across all of them. Assessment objective 3 is slightly more in, again, the first paper. Assessment objective 4 is the same, consistent, but the slightly less assessment objective 5s in the first one. So I'll give you another minute to have a look at those to see if you can reflect, if you agree with that, if you think back to your question, back to different papers. The other thing to notice is that the pure 2 and pure 4 are all the same. At least 55 of the 75 marks for assessment objective 1, assessment objective 2 on P1. And there's 50 out of 75 on the other pure units again. So it's worth noticing that. And that's a deliberate, that was a choice they made to facilitate the transition from GCSE to A-level. So again, considering that, they've structured the marks according to that one. If we look at the applied ones now, just to see how it differs from the pure. So here's the mechanics, statistics, and decision papers. And we can see here, if we look at the marks, the first 3 seem to be consistent on the first 2 assessment objectives. And you can then see how they slightly differ in the other assessment objectives there as well. So Examiners would have to ensure they're covering the content and as broad as possibly when they put the papers together, but they also have to adhere to these assessment objectives and the guidance to this when they put the questions. And that kind of then allows them to be consistent year on year on the difficulty, the demand, the accessibility, and the challenge of every paper. Where the students do not perform similarly, we'll come back to later on when we talk about raw marks and how they then convert those to them, ensure that the same number of students achieve similar grades year on year. This leads us to the first activity then, which will need our booklets. So give me 1 second, there we go. So if we look at the first activity from our booklets here, so if I scroll back up, so in this one here, we've got 2 questions that we're going to look at. And then what we need to do is we need to study those 2 questions taken from a recent Pure 1 paper and make a judgment about the assessment objectives and which one should be assigned to each question. So thinking back to those 5 examples of questions and a few things I've mentioned, and perhaps that that quick way of remembering the assessment objectives as well, the do it, show it, model it, interpret it, and calculate it. It's thinking about what assessment objectives are behind. The mark schemes and summary of the assessment objectives are available to you as well. So that's in the delegates booklet. And then, so if I go on to the actual booklet, so I can show you. So you look at those. So we've got 7 marks here to play with. And then it's thinking about what assessment objective based on the command words here, what the need of the question is, thinking about what assessment objectives those are. Similar with the second question, you can have a look at the mark scheme as well to see what kind of work they need to be doing it without having to solve the whole question. There's the assessment objectives there as well. And then what I'd like you to do is think about each question, which assessment objectives are behind, how many kind of marks they gave to each one of the questions here. I'd like you to, I'll give you some time to do this. So if we say about 5 to 7 minutes to do that, I will put you in breakout rooms now, so that if you want to discuss the actual questions with them and see if you can, because there is, when we have done this task before with others as well, there's sometimes a discussion and a dispute between should this be an assessment objective 2 or assessment objective 4, for example. So it's worth having that discussion. It's a bit difficult having it all together virtually here, but if it's 2 or 3 of you, that might help. So I'll put you in a breakout room now for that, just for 5 minutes. Have a look at that task. Please take your booklet if you haven't got it. Can I ask Claire, are they able to unmute before they go into the breakout rooms? Claire, can you hear me? I'd like to think. Sorry, Claire, can you hear me? Not sure if she can hear me. Any difficulties here? Right, I'll open the breakout rooms. Can I ask anyone who's online now, are you able to unmute? Just give me 1 second. Sorry about this. No, you can't. let me see if I can do it then, because I think I've got. Okay, so if can I change this for you guys? Sorry for this. I've got enable. Let me see if I can.
Hello, Melius.
Oh, sorry, Claire. Yeah, can we allow them to unmute themselves before I put them in a breakout room, please?
Yes.
Thank you. Okay, so if I now put you in breakout rooms just for 5 to 6 minutes, if you have a look at those questions, think about what assessment objectives are hidden behind each of those parts. Then we'll come back and discuss them as well. If anyone is having a problem with joining the breakout room, please let me know, and we can see if we can help you with that. So the breakout room should come up now. So if you click join, you'll be able to go into that breakout room, and please then use that time to discuss between you about this question. So 5 minutes, please, till 36. Some people have gone into breakout rooms by themselves, so I'll encourage you, if you could please click join so that you can work with your please click join so you can if anyone's having any difficulties, I mean, you're welcome to do this independently here as well, but I do encourage you to use the breakout rooms to discuss. I'll leave you to try the task, and then we'll come back. I'll be in the background. Minute, a warning, and they'll rejoin us. As we wait for the last 10 seconds for everyone to come back here, would anyone like to either unmute themselves or write in the chat the assessment objectives they think that question 6 here on the screen should be given? Please use the chat and just share your views on what assessment objectives before and see if we can sort of agree together. So question 6, what assessment objectives do you think? Thank you, Leo. Does anyone else agree with Leo, or are there different views? As you were discussing that, please share them on the chat. It's always good to have a look at the objectives as well. So if just to give you an example, this one, thank you as well. So we have objective 1 and 4, 4 and 5 with a question mark there. So what I'll try to do before if anyone wants to type again while I get the objectives back up as well. Let me try and get this from the slide. So it might be better to, if we bring this on this slide here. So that's the summary of them. But what might be also worth is if I copy this as well underneath it. So as I share with you, so I don't know if that's easier to see. Let's move that slightly higher. Right, so I'll move this as we go along. So question part 6a, we have a line with equation, meet the curve with equation at only 1 point, find the value of C. Now, in this case here, for part A, because they have to, if we look at the actual details of that, they have to recall and select some of the knowledge from facts for them to be able to do that. So there are, for that part A, they have 2 marks out of the 4 will be recalling those facts for them to know what to do. And then because then they have to come and show and put the arguments together, because if you look at this, so it's recalling and selecting the knowledge, 2 marks are given for that one. And then they have to be looking at mathematical arguments. Mathematical arguments are either them thinking about it or actually showing it with workings that they've done. So in this case here for part A, 2 of the marks are from assessment objective 1 and 2 marks are from assessment objective 2. Okay, so 2 and 2 in this case. The second part, it has a hence, find the coordinates of the points of intersection. So there's an element of that one that's actually an interpretation. And if we go and look at this again, comprehend translation of common realistic context in mathematics, but also interpreting the results. And one of the examples we showed earlier on had hence, and we said that's a way of saying interpreting this. So this one here has definitely assessment objective 4 because of them having to interpret what happened before and how to then put this in the context of part B. But they also have to recall facts again, which is another assessment objective 1. So therefore, we have 1 mark for an assessment objective 1, followed by 2 marks of assessment objective 4. So once again, you have 2 assessment objective 1, 2 assessment objective 2 for the first part, followed by 1 assessment objective 1, and then 4 for that one. So that's how we have to think about the problem here. Moving on to question 7. Can I ask again, thinking about what I've talked about for question 6, would anyone share their views either from the discussion they've had or from what I've just said now, what they think part A, B, and C, or any of those parts are, before I explain them as well? And again, it's just sharing the views. It is quite challenging sometimes to get our minds around this, but it's worth actually trying to see where each assessment objective fits in with this. So if I go with part A, it's find the area of the sector, giving you answer to 1 decimal place. You are right that there is an assessment objective 5 there because I have to calculate it. But there are also, for you to be able to do that, you have to again recall some information. So there is 2 marks of an assessment objective 1 in part A, followed by 1 assessment objective 5. So they are expecting you to recall knowledge and then use that to calculate the area here. So 2 marks for assessment objective 1 and followed by 1 assessment objective 5. If we look at the part B, given an angle that is obtuse, find the size of the angle ADO, giving you answer to 3 decimal places. So again, in this case here, we have 2 marks of an assessment objective 1. Well done. And then followed by 1 mark of an assessment objective 5. So every time you have to recall facts and from knowledge that you've learned, that's an assessment objective 1. But if you have to straight away calculate using those facts, like to make some calculations, that's an assessment objective 5. But if you have to put those to make an argument before you get to that, that's where the assessment objective 2 comes in. So in this case, though, it's 2 marks for assessment objective 1, followed by 1 mark of assessment objective 5. Then looking at the last one, we see that hence, find the perimeter of the shape, giving your answer to 1 decimal place. In this case, though, because you have the facts from before, it's about having the arguments in this case. So that hence we could perhaps think of it as an assessment objective 4 to interpret what we had before. But here it's more about putting those arguments together, which is an assessment objective 2. So actually, in this case, we have 2 marks assessment objective 2, followed by 2 marks of calculations, which is assessment objective 5. There is a justification, though, for it to be an assessment objective 4 based on the hence and interpretation that we mentioned. So that there's a crossover between the 2 assessment objectives there. So as you can see, there is a challenge when people write the questions, brand new questions, that they have to be careful and they have to be aware of that. And what makes it even more complicated, if we look at the next slide here, you have the content from the specification, the marks of the questions, and they have to ensure that the sum across all those questions add up to the totals that we mentioned in the previous table. And therefore, that can be quite challenging to write it and get it right as well. And that's why sometimes we feel that the papers, they're not as straightforward for our students, or the demand has changed a bit and therefore they need to be refining. But again, that's the scrutiny that has to happen beforehand. And that's something to be aware of. The other thing is, if we look at the following slide here, and look at this question here. So in this question here, a question can alter the distribution of the assessment objective mark. So if you look at,
他稀里糊涂着呢，所以他就改错了。
oops, sorry. So in this case here, this one relates to the difficulty of filling up the assessment grid. The question was originally allocated all 6 marks to an assessment objective 4. If the question changed to assess a different objective, though, you would have to then change the actual questions or the facts that you give. So if they have to interpret in order to do that, that's more of an assessment objective 4. So changing the words. So for example, if we look at if we look at all those, if we look at the first 2 sentences, figure 3 shows the design of a structure used to support a roof. The structure consists of, if we change that and then said, in figure 3, ACD is a straight line. And then that changed them immediately the assessment objective 4 there. The other one is, if we look at part B, find the nearest meter, the total length of the wood required to make the structure. If we change this to find correct to the nearest centimeter, the perimeter of the triangle, so you're changing that and telling them exactly what to do, it then changes again the assessment objective 4 to an assessment objective 1 and 2. Assessment objective 1, because I have to recall the actual the facts and knowledge, and assessment objective 2 is putting those together to solve the question. Whereas here, because they have to interpret the problem and realize what maths they need to do, they need to access to solve this, that's what makes an assessment objective 4. So again, if you look at those, changing those first 2 sentences into something more straightforward, and then which allows them to go straight to, you know, thinking about what maths they need to use and well, remembering it, and then putting that together to solve it, that's different to what they have here, where they have to think of what maths do I need to access. And that's the alteration of that question there. So if you were to change the question like that, then it changes the assessment objectives. Now, why is this important for us to be aware of? When we come to scaffold or break down the problem in the classroom, when we're trying to help them access it, sometimes our leading questions that we ask it changes the assessment objective of the problem without realizing. And a lot of us talk about problem solving and talking about, you know, the difficulty of the problem. And then the guidance that we give there, if we are more aware of this when we're doing that, then we're able to train them slowly and think about the tasks that we give to get them to that. There are some bronze, silver, gold questions for the A-level as well, where they do this. They change the scaffolding for us as well. So the bronze one will be similar to this, whereas the gold one will, for example, be like the previous version of this question. And for us, it's getting them from the bronze to the gold, and then it's training them how to access that. So whenever we break down a question and help them model that, we need to be able to train them at the same time to do that themselves. And that's the difficulty there. And therefore, the actual questions in the exams consider that as well. So be careful how many times you break it down for them, and ensure that you're also training them and showing them skills and ways to access that as well. Now, that also affects the demand of the question. When we say the demand is the difficulty as well. So you've got the demand of the question against the chat and the accessibility of it as well. If we look at this one here, sorry, I skipped this. I'll come back to that. If we look at this one, this is from an M1 paper. If I give you a minute to just read the question so you can see what we're talking about here. So this is 7 marks. It's a 7-marker question. It's quite unstructured for the students. If we were to then structure it a bit and put the questions, leading questions to get them to that stage, then we are basically altering the assessment objectives as well, and we're bringing more assessment objectives 1 and 2. So by doing that, you change the demand of the question. Yes, they are able to then practice the skills they've learned, but they need to be able to get to this level where they're looking at a question like this. And that's why when the examiners come and put the weight across the whole paper, there will be some questions where it's less structured because they're trying to see the interpretation as well. So that's just an example. I mean, if we look at an example for this one here, we could put some extra steps in between for that. Now, going back to this previous slide here, producing the finished draft of a paper requires a lot of skill to set the questions so that the assessment objectives marks the totals agree both across rows and down through columns. The other factor which has to be considered is the demand. What cognitive skills are required to do each question. Roughly speaking, the less structure in a question and the greater number of steps required to complete it, the more demanding it is. Also important is how familiar the question is likely to be to the student. So if it's something really unfamiliar because they've been very creative, they know that the demand will be different to something that's typically used in the exams. Linked to both of the above is the fact that the student may have to devise their own strategy. So which techniques to use may not be immediately apparent. So they consider these facts when they're coming and putting the paper together. And similarly with us, we can do the same thing. If we are teaching them a certain topic, we can find questions from the exam wizard, which I'll come back to later on, and throw that at some point, and then thinking, okay, we know that they know the knowledge, and we've practiced some AO2 kind of skills as well, where they put the knowledge together and they solve. I want to find an AO4 now. And I want to kind of see if we can help them, train them to access that. And you can actually have a lesson there before you move on, or put it towards the end of your lessons to then train them towards that. I'm quite confident that a lot of teachers around the world do that, but they think of it as a problem solving. It's changing that and thinking back to the assessment objectives so that we're thinking the same way as the examiners when they're putting the papers together. If we look at grade boundaries and how that all fits in with grade boundaries now, have a look here how that all comes together. So grade boundaries and the corresponding UMS were covered in Module 1. However, we'll mention a few things here. Grade A is about 80%. Grade E varies a bit more here, between 40 and 50%. So accessible. So they need to make sure it's accessible when they put together the papers together, accessible for the lower end. But to achieve an A, you can only lose a few marks. Usually an A star, you're trying to achieve at least 480 UMS. And that's something you can see from here as well. So I'll give you a minute to scan through this as well. And then what we'll do is we'll move on to the mark schemes afterwards. And then if you were with me yesterday in the GCSE version of this module, we were then looking at marking some of the exemplars and then thinking back. Now, in this case, we'll also be thinking about the assessment objectives that we've discussed and making sure that we are giving the right marks as well, but and looking at the different type of marks that are given. So I'll move on to the mark schemes now. But in order to do that, as I said, I'm going to explain the different types of marks that you can also get. So the purpose of mark schemes is to enable potential or full success to be rewarded, to ensure consistency between markers, and to ensure consistency from one exam session to the other. When the examiners have this is quite a bit more detailed than what we have. And again, it usually shows different other alternative methods of achieving marks, but it doesn't mean that those are the only ones. I did mention about the different type of marks as well. I'll come back to this here. So you've got the M for the correct method. It doesn't always have to lead to the fully correct expression for you to get that. We did mention this in module 1. You then have the accurate marks, which are conditional on the correct method marks. Also notice where it says there at the bottom, you cannot have an M0 with an A1. Okay, so you have to get your method marks for you to get the accuracy mark. The B marks, they're the unconditional accuracy marks, and they're used here. They're in different, and we'll have a look at those in a minute. Sorry. And then here, so we can also see a few statements about, for example, the M marks. There is often guidance for how to reward students who tries to use a method but not fully correct. So we'll see that in the mark schemes as well. An example here, in integrating a polynomial, the M mark is usually awarded if the powers of X are increased by 1. For example, in solving quadratics using the formula, sign errors are not penalized for the M mark. And those are just some examples here of where they could get the marks and where they couldn't. We do have though also the D marks as well. So D marks is mentioned on the slide here. We did cover this in module 1, but again, a reminder on this slide. So DM denotes method mark, which is dependent on the previous M mark. So if you don't give the first method mark, you are not going to be able to give the second one. So it mentions here, and they're used to denote where an incorrect answer can be used in a subsequent part and still be awarded marks, known as the follow-through marks. Usually there are conditions attached with this, and we'll have a look at an example in the next slide. So here we have an example. We need to look at the wording on here as well. For example, it says solutions based entirely on calculated technology are not acceptable. That means that if they use functions such as solve_n on a graphic calculator to just give them an answer, or if they use a graphic calculator where they look at the sketch and they get the answers from there, that they won't be awarded any. They need to show the working in order to access that. So they've been adding more and more of these sentences, and that's important for us to show and to our students as well, so that they can actually get the marks for this. We've been highlighting this more and more because of more and more students using different calculators to access and get the answers. So There are other problems as well, and we need to consider where else the calculator can cause issues, because I always talk to my students and I always tell them you need to show you're working. They seem to using different features of the calculator, skipping working and losing marks. And it's worth us discussing and looking at that in the next activity here. So here's an example here with the trigonometry, where they have to solve a trigonometric equation, and the calculator can actually cause them to lose marks because they're using steps to avoid that. So what I'd like to try again is give you a minute to think and write down what other topics may the calculator cause any issues. So do you know of any other topics that if they use the calculator, they can get the final answers, and then that can cause them an issue, but because they'll lose marks for not showing the working. Please use the chat here. I'll give you a minute to have a think and just share any other maths topics that you know that the graphic calculator or the scientific calculators can give them answers now, and then they can possibly lose marks because they use the calculator in the wrong way, or to kind of just skip some of the steps, so because they either don't remember or because they try to they either don't remember the method or they try to use it in a smart way where they don't value those steps. So again, use the chat, please. Okay, someone's mentioned surds. Any other topics that think back to the features, please? Yep, they use the equation solver on the Casio, skipping the factor theorem and long division, I agree. And then they don't show that. So having cubic equation using the Casio by avoiding long division. Yep, the solve function. Wrong angle mode, yes, that's also an issue of using radians and degrees at the exact value of 15 degrees. And with the solver there, you've got the cubic one, but you can also do that with quadratics, for example, as well. And they don't show the right steps for that. I don't know if anyone else has any other experiences with the students using that. Complex fractions, okay. If we think back to also perhaps the turning points as well. So locating the turning points, they could just put the graph they could use the graph mode as well. Simultaneous equations, these are the scientific ones do that as well now. So and also from a quadratic and a linear one, they can use the calculators as well, and they can find the points of intersection and then just put the answers there. And you also have the definite integrals as well, and they don't show the steps. They just put it in the answer down from there. Yep, with integration. And again, it's teaching them. It's not about avoiding the calculators, but it's about teaching them what steps they need to show. They can then use it for verifying, or they can use the technology for them to understand. But we need to train them how to maximize the marks, what to do and what not to do. So those were a few. Yep. Thank you for everyone's contribution in this one. And some of the ones we've just mentioned here are on the screen now as well. So those are topics to be aware of that students might use a calculator to get answers instead of showing the work and then verifying them. The other issue that we need to address is the type of steps that they need to show. So it's not just the calculator, it's showing sufficient steps. So if we look at this question here, 2 tan theta sine theta equals to 5 plus cos theta, and it says give you answers in degrees to 1 decimal place. If we take a moment to think about the sequence of mathematical processes that a student must used to do in part A, I want to ask you to write this one down, because we'll do another task in a few minutes where you'll have the opportunity to try that yourselves. By looking at the sequence here, here's on the other slide here, The solution requires the following steps. So I put some of the steps down from expressing, multiplying, replacing, rewriting, solving, and find all the required values of theta. The mark scheme must reflect this. So there are 5 processes here. There must be at least 1 accuracy mark for the final values. And this is where we always tell our students, look at the number of marks here and think about the ones for the final answer, and then think about how many other steps you need to show in order to achieve your marks. So this takes us to our 3rd activity. It's only a short one here because we'll have a longer one in a minute. So in this one, if we look at activity 3, so if I again bring the, if we go back to our delegates booklet, so if we scroll down to activity 3, the solution requires the following steps, which is what I mentioned earlier on. I'll put the question back up as well. Here's our question. So if we look at this, there are the following steps. There are 5 processes for 4 marks because one of them has to be an accuracy. Which 2 processes should be combined to get a single mark? So we have to combine some of these here because there's too many steps. So the expressing tan theta equals sine theta over cos theta, multiplying through by cos theta, replacing sine squared into 1 minus cos squared, rewriting the equation as a 3-term quadratic in cos theta, solving to find at least 1 value of cos theta and hence the theta, and then finding the required values of theta. But there's too many steps there, so two of those steps have to be combined to 1 for 1 mark. In the chat here, could you suggest which 2 we should combine, please? Anyone, if you have a think. So there's 5 processes for 4 marks, so 2 of them have to be combined. Any suggestions? So someone says A and B. Sorry, I'll put the question as well. I'll move this over. I mean, it's on the slide. Maybe perhaps I just leave the slide. There we go. I hope that helps. So there's the steps again. So you go 1, 2, 3, 4, 5. The last one is for finding the values. That's the accuracy mark. So which other ones? So that's, let me just make sure, because what I'm doing, if let me bring this over here. Sorry. So expressing here would be A, B, C, D, E, and F. There you go. So which of those 2? So some people, I'm just going back to the answers. A and B, C and D. C and D is also okay. C and D, A and B. A and B simplification takes 2 steps for 1 mark. C and D writing the cost takes steps for 1. A and B, A and B. So a lot of people are saying A and B could be combined. If we look at the mark scheme for this question. 1 second, let me get the mark scheme up here. Because there's our mark scheme here. So we can see there that A and B has been combined in this case here. So A and B has been combined to 1 mark. So expressing something into sine over cos and multiplying across, we can see from the mark scheme that that's been done for that first mark there. Then replacing the sine theta squared theta with this was given the second method mark. Rewriting this as a 3-term quadratic was the accuracy mark they gave there. And then attempting to solve this was the other method, 4th, with the final one as a fifth, and you can see that from here. So the A and B was combined, and it's worth noticing this in the mark schemes so that we can, when we're talking about the marks, when we're teaching in front of class, we can actually show them and demonstrate that as well. Okay, and there's a lot more information in the mark scheme, of course, with the note section at the bottom that you can have a look, and it's worth having a look at that. But again, thank you for the contribution for this. So this leads us to the next activity here. So in this case here, we are going to have two questions. You need your delegates booklet. We won't be in the breakout. We'll do this independently here because it requires a bit of time. So we're going to have to mark two questions, given activity 4. Mark the schemes that are available on the sheets as well. We're going to record the marks that we gave in each one, and then we'll come back together afterwards. If I bring back the... And this is this type of thing I would say you can, this is actually a task that's worth doing using the exam scripts. It's worth after every exam series to download a few of your exam scripts, save them, and then when you choose to use some of the papers for a mock or an assessment, to actually do some of that standardization yourselves or with your teams to make sure we are marking in a similar way that the examiners would. And choosing where to give the actual method marks, like in the previous case where we looked at that. So here's the activity 4 here. You will see the question again. Here's a student A's work, followed by a student B here. And there's the mark scheme with the notes that you can have a look at. And then what I'd like you to do is then choose how many marks you want to give for every section of that for each of the students. So we've got the question there, the student responses, and then please look at the mark scheme. How many marks does each, how many marks does each student get for that part 2 there, based on that. So let's give about 10 minutes, because you might want to actually solve the question yourselves first, and then refer back to the mark scheme and do that. If you have it printed, you can annotate it on there and you can share afterwards. If not, look at the Word document again. So let's give about 8 minutes. How many marks is this again? 5. So let's give about 8 to 10 minutes for you to solve, and then give the marks as you think, and then we'll come back together. So about 8 minutes, and then I'll give a prompt there. Thank you for everyone who's been sharing their responses. So if I give you 1 more minute, if you haven't, to type in responses, at least for the first one, if you haven't gone through the second one. So we've got some people saying 4 marks for student A. Yeah, a lot of people say 4 marks for the first student. Just scrolling through your answers now, 4 marks, majority, 3 marks for someone said. Okay, so for the first student, what they've actually given was they gave 3 marks out of the 5. And the reason they gave 3 marks is because it is correct up to and including the quadratic equation in cos theta. The student never wrote, in this case, theta equals to cos inverse of a third. So we do not see the full process. So they didn't award the method mark there, and therefore they wouldn't award the accuracy in this case. So they're quite strict with them. They wanted to see the cos inverse in that case of a third. You might agree, disagree with this one, but that's what they did with this one here. It's an exemplar, which you can find online. So you can also do that with your students as well. You can dispute that in some of the cases and see whether the senior examiner changes the marks, and sometimes they do, but they try to be consistent with every student. So yes, so that's 3 marks because of that one instead of the 5. And remember, if you omit that final method mark, you then cannot give the accuracy mark either if we follow those rules. If we look at the second student here, if I look back to your answers as well before I reveal what they actually gave, we have people saying 2 marks. Some others are saying 1 mark, 2 marks. So some have given the method mark and the accuracy mark, and others have just given 1 mark only. So people are between 1 and 2 marks for the second one. Looking at this one here, they gave 2 marks out of the 5. They gave 2 method marks. They didn't give them any accuracy marks for this one. They gave 1 method mark for the attempt to clear the fractions. And they gave 1 method mark for the use of the sine squared equals to 1 minus cos squared theta to get an equation of cos theta. No further marks were then given to the students. So they were given 2 method marks in this case. Now, this is a nice task that I always do as well, because I don't always get this right when it comes to my students, but I do that. I do check exemplars. I do check previous students' exams. So when I'm about to give an assessment, I want to make sure that I am going to be as fair or as strict as the examiners are, so that I can give a better indication to the students and they can learn from that before the real exam. So it is a task. We need to standardize our marking with the examiners for questions that we set, especially on high stakes mocks that we're doing. And that's one of the reasons why we chose to do a task like this with you today in the session. You can do that with your team. If there's more than 1 teacher that teaches the actual modules, it's even more important. I mean, we have about 5 or 6 classes of A-level at our school. And then we all mark our assessments, which therefore it's even more important that we do a standardized exercise before we mark our papers, so that we're clearly, because sometimes with the mark schemes, you look at the mark schemes and there is then a choice, or that it comes to our own interpretation. Yep, that fits in with that, that doesn't fit in with that. Doing a task like this on certain questions which have a lot more marks and perhaps are new to us, it's even more important. So that's the only. I've just read your comment. They've only given the 2 method marks in this case here, for those things. They haven't then given any further. It has to fit in with those processes that we also mentioned earlier on in our previous activity, and see how that fits in with this case here. You can see that cos inverse in here. That's what they were looking for. for the student A before giving that. So just putting this without this process here, they wouldn't have given that one. And again, here they've given the first 2 marks. They haven't given, they couldn't give any other method mark because the other method mark fits in with this here, but they never passed this stage here with the accuracy, which is why they couldn't give them any more marks. So it's important we have a look at those before we mark anywhere else. We also need to be thinking as well where students lose marks. So we've got students losing marks for different sorts of things and looking at common errors, which is where the examiner's report is important as well. Underneath the exemplars that you'll see on our qualification side, you'll have note sections from the examiners telling you about the trends and the common trends that are coming through each paper. As well as they also look at historical as well, and they tell you if that's an ongoing issue or not. So it's worth scanning through the examiner's reports of papers that you intend to use as well, but also after your students have sat an exam series to see what the examiners highlight. And then we have other kind of issues that come up. For example, here, there were considerable numbers of sign errors during this process, which led to loss of the A marks for correct quadratics. Another one from the examiner's reports, many only identified 70.5. Again, there was a noticeable lack of cast diagrams or graphs for this part of the question, which then led them to lose marks as well. So the need of the graph or the cast diagram isn't a necessity. However, that guides them through making sure that they don't miss any answers as well. Because some of them will use a graphic diagram and they can see that on there. But it's important to read those notes from examiners and then reflect in our own practice when we come to prepare them. Another question which caused a lot of issues as well is this one here. The curve C with the equation y equals f of x greater than 0 passes through the point 4, 1. Given that the f dash x of x equals to 4 root x minus 2 minus 8 over 3x squared, find f of x. If we have a think and use the chat again, where do you think students might have lost marks on this? What kind of errors would you expect? And that's the one on the screen right now. So looking at the screen here, this question here, where do you think that students would be losing marks on a question like this? Please use the chat to just share some of your views here based on your experience or your knowledge, or just looking at the question and thinking about this. It's worth actually sharing a bit of our knowledge on this. So where would students lose marks? Yep, forgetting the plus C after an integration. So that's a common issue there that even the principal examiner's report mentions on there. Any other ones that you think? Moving the 3 up together with the x squared. Positive x as well, yes. So the sign error, there's a sign change there when they move that. And then perhaps changing the signs by accident, or forgetting to change the signs as they integrate as well. Takes the derivative to find the secondary instead of, so actually I'm not understanding what they need to do here as well. The wrong antiderivative rule with a half degree. Yep, they could be misled by that one as well. A valid point. So it's looking at the question, thinking ahead of that, but it is worth when we are choosing a new question to also look at, because those misconceptions also are highlighted, and therefore it's a nice way to collect that and consider that. I think the more similar questions that appear on the exams, we have that knowledge and experience, and we know how to train them. But when they throw a new question every now and then with slightly more different structure, it's worth having a look at that. So, yep. So some of the points here from the principal examiner's report, similar to what you said, failing to add a constant in part B and making a sign slip with integrating here. So thank you again for your contributions within the chat. At this point here, I will go through a few support, and I've mentioned Exam Wizard, I've mentioned the scripts as well, and the qualification side. So I'll share again some of the further support that you can get from this, from us, and then I'll allow you to ask any other questions that you might have. So looking at the support that Pearson offers in regards to the delivery of the qualification, as I've shared throughout the events this week, they split them on a table as such. So you can see they try to, any resource they create or new one fits in with the criteria on the screen here. That you could see some of it is for the planning of teaching and learning, some of the exam preparation, and some are the results support afterwards. And then you can see the different tools they have within that. We had a lot of comments in the past about the international A-level not having enough resources to support this. So the maths team is creating resources. However, I would recommend you looking at the Maths Emporium as well, and looking at the A-level ones, and because there is a lot of crossover in many of the topics that you can then use some of the resources such as the bronze, silver, gold that I mentioned. There's topic tests as well, and there are themed kind of booklets as well that you can use within each one as well. The actual qualification side here, when you load it, if you go onto the course materials, which is on the left here, it then splits into different categories: exam materials, teaching and learning, and the specification and sums. So you can access that from there. The results plus I've mentioned before, but I'll highlight it again. Gives you a very good insight of the results that come out. What happens is once the students take the exams, exam papers are scanned, examiners then mark them, and then all the performance reports are shared then through the results plus. It's a unique tool that's not that other exam boards do not have. But from there, you can highlight your own class, your own departments or schools, performance against other schools, which then helps you kind of see the strengths and areas that you can improve with your students, and adapt your teaching or methods that you use, or even the time that's offered for that topic based on your schemes of work as well. So we've done adaptations to that through all this. Again, when you do a scheme, when you have your scheme of work, if you have any other resources you find online that tackle the issues that come up from the results plus, we usually highlight them with a hyperlink on our scheme of work, so that year on year we don't forget some really good resources that are out there. Sometimes we ask the Pearson to create some of that as well. When it comes to technology as well, some of them can help us for students to visualize and to make those links, to ask more open-ended questions, to ask different variation of the question, and that's quite useful as well. And we adapt and we create and prioritize the topics based on what comes out from the results plus. Exam Wizard is always good, but it utilizes the past papers. Again, you might choose the international A-level here, but you might choose also the A-level and take some questions from the A-level that students won't be used to or won't have access to, because they always look for the international A-level. And then you can pull some of those questions and use them as a part of the homework, or a part of those AO4 kind of questions that we talked about earlier on. And perhaps get the students to write down, you could ask the students to write down those adapt the question and put some more scaffolding, and instead of you doing that, you can ask some of your students to do it together. So not just answer, but ask what questions can be asked instead. Those are nice questions for them to start to learn to process the problem, and scaffold it down. And with that discussion that you'll have with them by doing that, you're training them how to break the question down as well. The access to script, which is you'll need to log in through the Edexcel online to access this. If you haven't got access to that, please talk to your exam officer at the school, and they can sign you up and allow you to access this. It's worth always, either if you don't download the whole class, depending how many students, downloading some of the students who've got the really high grades, middle or low grades that year, and having a look at the exemplar, looking at their work. You won't have any comments from the examiners on that or any ticks or crosses. You'll just have the allocation similar to what we've done in our tasks today. You can use that for yourselves, but you can also use that with your students. You can get your students to do a similar task that we've done here. And then that discussion then with you and the students could then help them understand what type of working they need to show. So that's something I utilize quite a bit. But instead of doing that, you could also use their own work so you could take a photo, scan some of their pieces of work and put that in a random way on a bigger sheet and ask them to mark it themselves again. So they don't know if they're marking someone else's in the class, or you're not affecting anyone's confidence by showing them, but you could do that in a similar way with them as well. And that's the access to scripts that you can have. In terms of paid resources, there are the corresponding student books that you can have from Pearson. Remember, that's a publishing. It doesn't guarantee that it doesn't guarantee just because you're using the publisher's resources, you have an advantage over any other publishers as well. It's always worth making sure that you refer back to the specification if you're new to the international A level. And you are going hand in hand. If you've gotten a few years of the new if you've taught the new specification for a few years, then I'm sure you'll be fully aware of what the content is. There are the active books as well that you can have the online version. I've mentioned the textbook, the publisher's one. You don't have to have it. You can have from other publishers as well. Remember, the important one is the actual specification that you need to refer to. This textbook here, they try to have exam practice questions within this. And then to some of the transferable skills that they should have, they try to incorporate within that as well. No textbook's perfect though. So it's always worth having a look at what other resources are there to complement this. If you want to contact us for any other type of support or any other training sessions, it could be a topic specific one or one of the applied as well. And when we highlight a few of the things that the examiners do, looking at the marking towards it, looking at some ideas within that, please send an email to the email you see on the screen, which is also available on the website. Mark Heslop is one of the subject partners here, and then himself or one of the credible specialists like myself will either do a virtual one, or sometimes we come into the area as well. The other person to contact as well for asking for this support or to chase a few things for yourselves is the Pearson local representative, who then works with us. And then sometimes we organize face-to-face network sessions as well. It's always good to have schools to partner and talk about the maths themselves and share some of the practice. At this stage, I'm going to stop. If there's any questions to then pass it to yourselves. If you have any questions that you'd like to ask me, I'll be here. We've got a bit of time, so I'm happy to ask and see if I can support. If you have no other questions, I'd like to thank you again for joining me in the last two modules. At this point, I'll also ask Claire. Claire, can you hear me?
Yes, I'm here.
Hi, Claire. Could you also share the WeTransfer link to the slides that I used today on the chat? So before anyone goes, they can click the link to download or copy the link. Thank you, Claire. So the link now in the chat has the slides from today's session, which you can then either go back and have a look yourselves or share that with any other teachers from your department or your school to then go over with that. If you don't have any other questions once you've taken this, remember you'll get an email with the certificates as well as a feedback for the last two sessions, which I'd be happy if you could share. And within that feedback, it's not just about the session today. There's also an opportunity to request any other further support that you might want us to offer. And then if you have any direct questions coming to me, you can even mention them in that feedback, or when you send an email to the Teaching Maths, you can mention my name, Elias Michael, and then ask for anything, and they'll share that with myself, and I'll try and support and get back to you as well. If you don't have any other questions, I'd like to wish you a good rest of the day, wherever you are. And if not, I'll be in the background here to answer any specific questions. Thank you again for joining us today and for this week. Have a great rest of the day. Thank you.